Hello everyone, and today we're going to move on to the next topic, which is the accumulator style function. This is another thing that is adding on to the things we have learned before. So it's not generative recursion or structural recursion, but it's something tangent. It's trying to help us to solve problems that would be otherwise difficult to solve. Right? The idea of accumulator, right, is that we want to accumulate some knowledge on the side as we are processing um, some data. Right? I'm going to show you an example why that this can be convenient. Okay, so let's say you are traveling from a starting point. You are going to pick up a grocery. You're going to go to school, and then you're going to go to gas station, and then go back to your house. Go to your house eventually. And the distance between the places are, let's say, from your starting point to grocery is 7 mile, from grocery to school is 4 mile, from school to gas station is 11 mile, and then from gas station to house is 8 mile. Um, you want to keep track of how many miles you have traveled from the starting point of the trip, right? It's as if you are building an odometer that tracks the mileage on your car. Okay, so that's the problem we're trying to solve. Essentially, this is a function called the total distance that takes a list of numbers, so which are the relative distances between the locations, and you want to produce another list of numbers, which are the total cumulative distance from the starting point, right? So for example, from your starting point to grocery is 7, from your starting point to school is 7 plus 4, which is 11. From your starting point to gas will be 7 plus 4 plus 11, 22. And then starting point to a house will be 29. To a 30, sorry, 30. Right, so we have that first check spec reflecting this image. Okay. Um, Right. So once you know that problem, right? If we follow our design recipe, we have our signature, we have our check spec, we have our purpose here. Let's build our function now, right? So the first intuition we might have is that okay, we are processing a list of number. Let me do my list of number template that we have done 1,000 times. So it's going to be empty a list of number. We will do something about it, and then otherwise it's accounts. And if it's accounts, we can get the first of the list of numbers. We can also get the rest of the list of numbers. And naturally, we want to do a recursive call at some point, right? So if you have this, right, this is our first attempt. This is our template, okay? So following the template, right, we will try to solve this problem based on the hints from our check expect, right? So if it's empty, naturally the output should be empty. And otherwise, if there's a number, right? For example, if we only go to one location, we just create a list with a number back. So we know that we will return a list. Very likely, this should be counts. Very likely. Okay. So this is our first attempt. And if we run this though, you will notice we actually didn't do anything. Right, so our input is 7, 4, 11, 8, right? Input is 7, 4, 11, 8, where output is also 7, 4, 11, 8. Different from our expected answer, because if you look at this, we didn't do any math. We just say, okay, given the list of numbers, I will, create a new list with the first number in the front, and then recursive call on the rest. We didn't do anything with the numbers. In fact, what we want to do is that we want to say, okay, the distance for the second location should be 7 plus 4. The distance for third location should be 7 plus 4 plus 11, right? The distance for the fourth location should be 7 plus 4 plus 11 plus 8. There should be some addition happening, okay? Right, so then you might think, okay, naturally, let me do some addition, right? Let me do addition. So let me do addition here, right? And the problem, though, for this is that here is a number, while the rest is a list. You can't just do addition like this, right? The thing we want to do is that we want to add this number to every single number in the rest. Okay, I'm going to give you 2 minutes. Pause this video, try it yourself. How do you add this number to every single number in the list? And see if you can make it work. Okay, so let's say, assuming that you have already tried that yourself. If you haven't, pause the video and try it. So let's say you already tried it yourself, right? We are trying to add this number to every single number in the rest of the list. This is a classic map. Let's do that. So we want to map every number in the list, in this rest of the list, in a way so that we add a number to them. So the operation we want to do is that we want to add the number to every single x in the list, right? The number we want to add happen to be the first number, if you think about it, right? So we want to add a 7 to 4. We want to add a 7 to 11. I want to add a 7 to 8. We want to add a 4 to 11, 4 to 8, 11 to 8, right? That's what we want to do. Okay. So however, it's our first try. If we run this, it didn't work. We didn't get the 7, 11, 22, 30. Instead, we get 7, 11, 29, 55. These two numbers are too big. Why is that? Because if you think about it, when we call this on the input, on this input, right? If I call this thing on my sample input, the first thing I get is a cons 7, and then it's going to recursive call. It's going to recursive call. It's going to get the rest of the list, which will be 4, 11, 8. So far, so good. And it's going to add the first number, which is 7, to every single number in this list, right? So it's going to do this map. Now this map is easy, right? Just add the 7 to each number. So that's going to be a list of 11, 18, and 15. Okay? And it's going to once again recursive call on this total distance. So this whole expression, we're going to evaluate this part, and that becomes this. The first number now is 11. The first number now is 11. And the rest of the list is now list 18 and 15. Okay? And if we continue, if we do this map, this becomes adding 11 to every single number in the list, becomes list of 29 and 26. Okay? And if I keep doing, if you will see where the issue happens, is that you might now get, you're going to evaluate the total distance, this one, right? It's going to call counts. And the first number is now 29, and the rest of the list will be mapping on the list 26. And the first of the number will be 29. So this will create a list of 55 because it's 29 plus 26, right? And then if you have only one number, total distance for that one number will be just itself. So you get eventually this, right? So this is why you get 7, 11, 29, 55. 7, 11, 29, 55, more than what we want. If you think about it, you got 29 because you did 29 is equal to 7 plus 4 plus another, so 7 plus 4 is 11, right? Then you did, and 18, you get that from 7 plus 11, right? So 7 plus 4 give you the first 11, 7 plus 11 give you the 18, right? That's what you get, 11, 18. And then when you do this one, when you call this total distance, you are adding 11 to 18. So you're adding it together, and that's why you get 29. Problem is here, you don't want to add this 7, right? You somehow counted the distance from starting point to growth rate twice. You don't want to count it twice. You just want to count it once. Now, if you don't have that 7, you will have the right number, which is 22, right? Right. So we see this issue. Now, how do we get around this? I will give you 2 minutes to try this. Pause the video. All right. So, okay, one thing you could do is that you don't want to do this mapping inside the recursive call. You might want to do the mapping outside. So if I move this mapping outside here, right? Let's say what I'm trying to do is I'm trying to get the list of numbers first, and then add this first number once to every number in the list. Right, this will actually work. Let's see. Okay, I think the parenthesis is fixed. And if we run this, yeah, we actually passed the test. These are related to the next problem, so ignore those. Right, so this one actually works. Right. So I guess the point I'm trying to show you is that without accumulator, if we follow our old style to solve this problem, it's not that obvious how to do it. Okay. I can show you another solution that may be more intuitive than what I have here. It's okay. Let me show you a different solution. So let's say I still have my define my function, right? And instead of doing what we were doing here, right? We kind of see that what we're trying to do is that we're trying to add a number to every single number after. Add a number to every single number after it, right? So let's define a helper function called add to all, right? I'm going to put that here, right, to save time. So this is a very simple function. It's just saying, okay, given a number n, given a list of number, we're going to use a map to add the number n to every single number in the list of numbers. Okay. And once we have this function, we're going to do it. We're going to use it in our count. And we will still follow the template. Okay, empty a list of number. If it's empty, then it's empty. And then counts a list of number. If it's a counts, we will do something with the first. We will recursively call total distances on the rest. Right. Okay. So we know that there will be counts here because we want to eventually return a list. So this must be a counts. And what remains is that how do we handle this, right? So given the total distance in the rest of the list, what we want to do is that we want to add a number to each one number here. So we want to call add to all. So we're going to call add to all. We're going to add a number to all the distance after it. The number we want to add happen to be the first number in our list, right? So that's also a correct solution. And if you think about it, these two are the same essentially, it's the same, right? This one not so clear why we did this, but this one is more clear because we want to add a number to all the list of numbers. Okay. Well, I messed up my parentheses somewhere. Okay, if I run this, it still pass. Okay. Okay, now I want to transition into the next topic, accumulator, right? If I use an accumulator, if as a human being, right, when you travel this road, you keep a number in your mind, right? That's how far you have traveled so far. And if you have that number, it's very easy for you to say, okay, the distance from gas, I have traveled 7 miles to grocery, right? If I go to the school, it's going to be 7 plus 4, right? I have traveled 11 miles now. And if I go to gas station, it's going to be 11 more miles, so it's 22 miles. And now if I go to house, it's going to be 22 plus 8, 30 miles, right? So if I keep a number accumulator that tracks how far I have traveled so far, then the problem is a lot easier and a lot more intuitive. Okay, let's try to solve it that way. So we're going to define our function. Okay, define total distance, and I'm going to rename this input variable to a list of numbers 0, and I will explain why in just 1 second. Okay. So to do a accumulator style, right, I'm going to define a second version of the function. It's going to be a helper version. The function will be essentially the same, right? It's going to be essentially the same. I'm going to still call it define total distances, and I'm going to add a ACC here at the end, right? I'm going to add that at the end to signify that this helper function is trying to help me do the accumulator style, right? It's also going to take in a list of numbers, but it's also going to keep track of the distance I have traveled so far. That's my ACC, my accumulator, right? So ACC is the accumulator, right? Keeps track of the sum so far. Okay, and if you want to be very rigid, right? Very stringent. You could put your signature, purpose, and check spec for this function here, right? I'm going to copy and paste that here. So the purpose for this, the signature for this function will be taking in. I'm going to do slash here. Taking in a list of number and an accumulator, and output a list of number. Now, what's the purpose? The purpose will be given a list of relative distance, a list of relative a long. I'm going to produce a list of total distance, total cumulative distance, given the distance I have traveled so far. So this ACC is the distance so far, right? Now we can build this function. So it's going to be naturally another count because we are processing list, right? And empty har, if the list of number is empty, right, naturally empty, there's no place to travel to. And if I have anything in the list, I will do something with the first of the list. I will also recursive call on the rest of the list somehow. And here is the important thing, the ACC very likely will change, right? So I'm going to put ... here. So what do I do with the first of the list? I know that there will be a counts because I want to eventually output a list. But I also want to modify the first of the list because ACC is the distance I've traveled so far. This is the distance to the first location. So I want to add them together. Okay. And this becomes the cumulative distance to the first location. Right. This will handle the first location correctly. Now I can move on to the rest. Okay. So in the rest, what happens is that recursive call remains the same, but my cumulative distance is going to increase. Right. If I have traveled to the first location, I now have my ACC is going to be increased by that much. Okay, so that becomes my new accumulator. All right, so that's my local helper function. And once I have that helper function, I'm going to call this helper function with my original input, a list of number 0, and a starting point for my ACC. So when I start my trip, how far have I traveled? I have traveled 0 miles. So 0 should be my starting point. And this will make it work. So if I run this, he still passed the test. Okay, now let me briefly explain why I named this a non-zero and I named this a non. The reason is that if I name this a non-zero, it will still work. It will still work, but there will be some confusion, right? If I refer to a long here, am I referring to this a long, or am I referring to the input, the original input? So this way it's nicer, and it lets me know that okay, in my helper function, I work with a long. That's not the original list of numbers. But when I call my helper function for the first time, I'm going to pass in the original list of numbers with an accumulator. Okay. Okay. So this is the accumulator style function example. All right. So one more thing to further explain this. Let me show you if I call this function on my input. Let me show you a walkthrough. All right. So if I call this, right, what does it evaluate to? Right, it evaluates to, first of all, it calls this helper function with accumulator 0, right? And then what happens is that it's going to call my helper function, which is a const. The input is a const, is a list. So it calls this part. It's going to const. It's going to create a list, essentially. And I'll replace this const with a list just to make things simpler, right? It's going to create a list, and the first number of the list will be accumulator plus the first number of the list, which will be 0 plus 7. So that's going to be 7 here, right? And then the rest of the list will be this, okay? Which is what? Which is, this is essentially list of 4, 11, 8. And this is the distance you have traveled so far. You have traveled 7 miles. Right. Right. So if I continue, this will become list 7, right? That doesn't change. This part will create another const where the first of the consts will be ACC plus first. So it's going to be 4 plus 7 will be 11, and it's going to recursive call. In the recursive call, the rest will be a list of 11 and 8. And the ACC once again will change. The ACC will be the old ACC 7 plus 4. So this will be 11 now. That's the distance you have traveled so far. So notice that this is 11, this is 11, right? And then if I continue, this will now become 11. Sorry, not 11. It's going to be 11 plus 11, right? So it's first plus the ACC, 22. And then it's going to recursive call on the rest of the list, which is just 8. And the accumulator now will be 22, right? And if I call one more time, I should get my final answer, which is 8 plus 22, 30, right? That's the right answer I'm looking for, right? So this is showing you a workflow of the whole thing. Okay, I'm going to comment this out now. All right, so once you have seen this example, you can now scroll down to the description here. This explains how you can build an accumulator function yourself, right? So read through this yourself. I'm going to focus on the steps here, right? So first of all, you follow your design recipe. You do your template, signature purpose, and check expect. And then you revise it, try to add an accumulator. How do you do that? First of all, you need to know what you are trying to accumulate, right? In this case, we are accumulating the distance we have traveled so far. and the distance is a number. But it could be anything. You could be accumulating number or string or list or images. Right? And once you know what you are accumulating, you're going to make a new template, make a helper function. That's your local definition inside the main function. And in your helper function, you will use the same parameters. You will rename them slightly so that they don't have name conflict. And you will add one more parameter for your accumulator. In my case, I can show you real quick. In my case, this is my helper function. It has the same input as before, but have one more parameter for accumulator. And then you are going to apply the template. In my case, it's a list processing template. And you will try to build that template and figure out how do you modify the accumulator. In my case, I know that every time I travel to the next location, I should increase my accumulator by that amount. So this is how I modify my accumulator. Right. And then eventually, once you have your accumulator set up, your primary function is just going to call the accumulator function with some initial value for the accumulator. All right.